Hey everyone, have you ever wondered how scientists can prove that something actually causes a change over time? Well, today we're going to break down the powerful statistical tool they use to do just that. It all starts with a pretty simple question.
So imagine this, a new program comes out, and it guarantees it can make you more confident. That sounds amazing, right? But how do they prove it? How can you be absolutely sure that any change you see isn't just, a random fluke? That's the exact problem we're going to tackle.
All right, so first up, the challenge of change.
Look, measuring someone's confidence one time, that's easy. But what if you measure them before a therapy, right after it ends, and then again a few months later? Now it gets tricky. See, everyone's different. People start at different levels. What we need is a tool that can cut through all that background noise, all those individual differences, and zero in on the one thing we actually care about, the change caused by the therapy itself.
So what is this special tool? Well, let's meet the hero of our story, the Repeated Measures ANOVA. At its heart, the Repeated Measures ANOVA, and we'll just call it ANOVA for short, it has one very specific job. It's designed to find out if there's a real statistically significant change when you measure the exact same group of people at 3 or more different moments. Now, if you've ever heard of a paired t-test, you're already halfway there. A t-test is perfect for comparing just 2 points in time, like a simple before and after. But the ANOVA, think of it as the t-test's bigger, more powerful sibling. It lets us look at the whole journey, before, after, a 6-month follow-up, all in one single elegant test. So why do researchers love this method so much? Well, first, it has way more statistical power. Since you're always comparing people to themselves, you filter out all their individual quirks. That makes it much easier to spot a real effect. It's also super efficient. You need fewer people for your study. And best of all, it lets you map out the entire trajectory, the whole story of how that change unfolds over time. But, it's not a silver bullet. Researchers have to watch out for a couple of potential traps. For instance, people might get better at a task just because they've done it before. That's a learning effect. Or the effects of one treatment might linger and carry over, influencing the next measurement. This is why having a really smart, careful study design is absolutely crucial.
Now, for the ANOVA to work its magic, it has to follow one critical rule. Think of it as the main rule of the game. And it has a fancy name, sphericity. To trust our results, we have to know the test is being fair, right? How can we be sure that the way we're measuring change is actually consistent across all the different points in our study? And that's exactly where sphericity comes in. I know it sounds really technical, but the idea behind it is all about fairness. It basically means that the variability in your measurements should be consistent over time. The difference between time 1 and time 2 should be about as variable as the difference between time 2 and time 3, and so on. We're just checking to make sure the comparison is stable all the way through.
Here's probably the best way to think about it. Sphericity is like making sure your yardstick is reliable. If that yardstick stretched or shrank every single time you used it, your measurements would be totally meaningless. This assumption is what makes sure our statistical yardstick stays the same from the first measurement to the last.
And ignoring this rule, that's a huge problem, because if the sphericity assumption is violated, the test can basically lie to you. It might spit out what we call a false positive, making you think you found this amazing significant change, when in reality, there was nothing there at all. Okay, let's bring this all back down to earth and see how it plays out in our example. We're back to that therapy program that's designed to boost confidence. So the researchers gathered their data. They measured the confidence of 30 students at 3 different times, before the therapy, right after it finished, and then again 3 months later. And just take a look at the average scores. You can see a really clear trend. Confidence starts at 19, jumps up to nearly 22, and then climbs all the way up to 25.
The numbers are definitely going up, no doubt about it. But here's the million-dollar question for any researcher. Is this a real, meaningful increase, or is it possible this just happened by pure chance?
To get the answer, they ran the Repeated Measures ANOVA, and the test, well, it delivered a very, very clear verdict.
Boom! The result was a p-value of less than 0.001. In the world of statistics, that is a slam dunk. The p-value tells you the probability that this result happened by random chance. A number this tiny means it is extremely unlikely this was a fluke. The increase in confidence we saw was real.
Okay, but what does that result really tell us?
Let's move into our final section and see how we go from that one single number to a real conclusion. That super tiny p-value is powerful, but it's also a little bit vague. It's basically shouting from the rooftops, "Hey, a significant change happened here." But it doesn't tell us when it happened. Did confidence jump right after therapy? Or did it grow more during that follow-up period? To find that out, we have to dig just a little bit deeper.
It's really a two-step process. The main RM ANOVA is kind of like the gatekeeper. It tells you if there's even a change worth looking into. Once you get that green light, you run what are called post-hoc tests. You can think of these as a series of head-to-head matchups, where you compare every time point against every other time point to find out exactly where the significant jumps happen. And for our confidence study, the results of those follow-up tests were crystal clear. The initial jump in confidence right after the therapy, it was significant. And what's even more impressive, the growth in confidence continued to be significant during that 3-month follow-up period. The therapy didn't just work, its benefits actually kept growing over time.
And listen, this isn't just for therapy. This exact method is absolutely essential across so many different fields. It's used in clinical trials to see if a new drug works over several months, by marketers to track how customers feel after a big ad campaign, and by educators to see the long-term impact of a new way of teaching.
So, in a world that's just full of random noise, the repeated measures ANOVA gives us this incredibly clear lens to see true, meaningful change. It helps us understand not just if something works, but how it works over time, which really just leaves one final question for you. If you had a tool this powerful, what important change in a world would you want to measure?